Okay, so today we are going to get into trigonometry. So if you haven't grabbed out your notes packet already, you should do that. Open up to page 8. Furthermore, if you are someone who fills in your postulate sheet as we go, now would be a good time to grab that out as well. Now, trigonometry, you may have heard of this before. I know some of my other classes talk about it, and trigonometry is an entire branch of mathematics, kind of like geometry, kind of like algebra, but some of the more basic building blocks of trigonometry are things that we use actually quite a bit in geometry because, one, they're pretty straightforward to do, but also they help us with things moving forward. So trigonometry, by definition, is the study of the relationship between side lengths and angle measures in a right triangle. So I'm just going to emphasize that it must be a right triangle. If it's not a right triangle, you can't do trigonometry with it. At least not the type of trig you're going to learn yet. Now, when we're working with trigonometry, the basic building blocks of this branch of mathematics are what are known as the trigonometric ratios. And if you prefer, we can just straight up call them trig ratios. Now, on your postulate sheet, you're going to see a section that focuses on trig ratios. It's not truly a postulate or a theorem we're working with here. We're working with definitions, but we are going to put some stuff on our postulate sheet so that moving forward into future chapters, we've still got our basic trig stuff that we can use, specifically those ratios. Now, in order to work with the three common trig ratios, and there's technically more than three, we mainly use three in most math and especially in geometry. In order to work with these trig ratios, first off, we've got to have a right triangle, and I am going to name the angles of this right triangle A, B, and C. Now, these trig ratios work in the idea of you focus in on one of the angles. I'm going to focus in on angle A, and it has to be one of the acute angles in the triangle. And when you focus in on that angle, its relationship to the sides can form these ratios, these fractions, that can help us solve for either missing angles or missing sides in situations with triangles where you don't have enough information to use Pythagorean theorem for the sides, or you don't have enough angle measures to find the angle because angles add up to 180. So, in order to work with this, the first thing you have to do is you have to identify your sides. Of course, the hypotenuse is the longest side. And remember, the hypotenuse is the side that's not only the longest, but it's always across from the right angle. The other two sides, the legs of the triangle, have specialized names when you're doing trig, though. The side that is on the other side of the triangle as the angle you're focused in on. So like if you're focused in on angle A, we would refer to this as side A, but it also, when doing trig, is known as what's called the opposite. The opposite side. And then the side that's right next to the angle A, that's one of our legs, is known as the adjacent. And I'm going to turn my notes sideways to write this. A, D, J, A, C, E, N, T. So the three trig ratios work with these three sides of our right triangle, and the three trig ratios are known as sine, cosine, and tangent. Now, when we work with these trig ratios, first off, we don't tend to write out their full name most of the time. They each have a shortened version of the first three letters. So sine goes S-I-N, cosine goes C-O-S, and tangent goes T-A-N. And you may have seen these buttons on your calculator. And we're not going to get to these buttons on our calculator today, but we will be moving in that direction. Now, you're never going to hear me refer to them as sin, cos, or tan either. They are sine, cosine, and tangent, and that's how I'll refer to them. Now, in order to make these ratios and to make them work, they all go back to that fact that you have that angle that you're focusing in on. So after you write the three-letter name, sine, cosine, or tangent, immediately after that has to go an angle. In this case, we're focusing in on angle A. If I knew the measurement of angle A, for example, if I knew angle A was 20 degrees, I would put 20 right there. In this setup, we're just calling it angle A. And if you don't know what its measurement is, you just put its name. And these ratios are equal to fractions made with the side lengths in a specific order. Sine is the opposite side of the triangle getting divided by the hypotenuse of the triangle. Cosine is the adjacent side getting divided by the hypotenuse. And tangent is the opposite side getting divided by the adjacent side. Now, you got to be careful when you're working with trig, because it really, especially that opposite and the adjacent, those will change where they are located depending upon which of the angles you're focusing in on. For example, if I had focused in, and you don't have to do this, but if I had focused in instead on angle B, the opposite would have been what for angle A is the adjacent. And the same is true about the opposite. The opposite of A is the adjacent to B. Whoa, that's not what I meant to do. Go back. I'm clicking the wrong button. That's why I'm having issues. Helps if I click the right thing. There we go. So, those opposite and the adjacents will flip depending upon which angle of the triangle you're focused in on. Now, one of the things that kind of helps us with memorizing which one goes with which, because it is kind of good to know which ones go together without having to look at your postulate sheet all the time. But there's a memory tool known as SOHCAHTOA. And you'll hear me reference SOHCAHTOA a lot. In SOHCAHTOA, the beginning letter of each of these, the S, the C, the T, stand for sine, cosine, and tangent. And then the other letters, the O's, the A's, and the H's, represent opposite, adjacent, and hypotenuse. So for SOH, S-O-H, it's telling you sine, is opposite getting divided by hypotenuse. That's what the O and the H tell us, is it tells us what order and which sides. Cosine, adjacent, hypotenuse. Cosine is the adjacent divided by the hypotenuse. TOA, T-O-A, tangent is opposite divided by adjacent. So you're going to hear me reference SOHCAHTOA a lot. So today, when it comes to working with our trig, we are going to focus in on writing these ratios, just making these fractions. Nothing above and beyond that today. Our focus is these fractions because we have to get these fractions down pat. Okay, so find each of the trig ratios for the following. Write the answer as a simplified fraction. Generally speaking, trig very rarely is going to have a ratio that's equal to decimals. It just doesn't work with decimals. Like, it works, but we just don't do it. We work with fractions, and there's a reason for that. So, we want to do sine of A, cosine of A, and tangent of A. That is very important to look at on your problems first, because if those angles were not all A, that would mean I have to be careful with how I approach my triangle. Since they are all A, that means the opposite and the adjacent are not going to change in this picture. So, here's my hypotenuse. Whoa, let me try that again. Which I generally just put an H or an HYP on just to kind of help me identify. Opposite has to be across from the angle that you're focused in on in your ratios. Since they were all of A is our angle that we're focused in on, which means go across the triangle to get to the opposite. So that's O, and this would then be A. I don't know why I just wrote H. My goodness. Okay. Sine. Again, SOHCAHTOA is my memory trick. Sine is the S. It goes O and then H. So sine of A equals O, 15, divided by H, 39. Now, our answers need to be simplified fractions. We can't leave it as 15 over 39 because 15 and 39 both have a common factor. They both have something in common that they will divide by. Specifically, they will both divide by 3. And you get 5 over 13. Cosine is the adjacent divided by the hypotenuse. How do I know that? Because C-A-H. C is cosine, A is adjacent, H is hypotenuse. So cosine is 36 divided by 39. Again, simplify your fraction. Both of these also will divide by 3. And you'll get 12 over 13. Okay, we got one more for this problem, and that is tangent. Tangent is the TOA in SOHCAHTOA. So TOA, T for tangent, O for opposite, A for adjacent. Tangent is the opposite divided by the adjacent. 15 divided by 36. Again, simplify your fraction, and I happen to know that both 15 and 36 will divide by the number 3. And I get 5 over 12. The nice thing about simplifying these fractions is, generally speaking, if you're working with whole numbers, they're all going to divide by the same thing. So if you recognized 15 and 39 both divided by 3, then most likely the other ones are going to be divided by 3 too. It's kind of a nice little trick that you can work with. Okay. Once you got those, flip to your next page. Now, I've got both of my pages up at the same time for a reason, because I want you to look at these triangles together. You will notice they are the exact same triangle, and that is done on purpose to kind of point out what I talked about earlier. In this problem, we are doing sine, cosine, and tangent of B, which means our angle that we're focusing in on is this one this time. The hypotenuse is still this, but my opposite, on the opposite side of angle B is this one, and the adjacent is this one. Now I'm going to write SOHCAHTOA on top so that we have that. And now, I can start writing my ratios. Sine. Sine goes SOH in the SOHCAHTOA. So, O stands for opposite, 36. Divided by H stands for hypotenuse, 39. 36 over 39. Again, on this problem, it's all dividing by 3's, so you get 12 over 13. Cosine. That's the CAH of SOHCAHTOA. C stands for cosine, A stands for adjacent, H stands for hypotenuse. So, A is 15, hypotenuse is 39. Divide by 3 to simplify our fraction, and that's 5, and that's 13. Tangent, same idea. That's the TOA in SOHCAHTOA. T stands for tangent, O tells us the opposite, and the A tells us the adjacent. And it also tells us the order. The middle letter always goes on top. The last letter in SOHCAHTOA goes on bottom of the fraction. Divide both numerator and denominator by 3, and we get 12 over 5. Now, this is going to be our main focus today, but sometimes you're going to have some things where they get a little bit harder, similar to our last section of problems here. It still says to do the same thing, to find each of the trig ratios for this triangle. Write them as simplified fractions, but there's two things that make this problem a little more challenging. First off, if you look at your trig ratios, it goes J, then it goes K, then it goes K, then it goes J, which means when we do our ratios, our SOHCAHTOA, while the hypotenuse never changes, the opposite and the adjacent will. So you have to be careful on which angle it's focused in on. Now the hypotenuse, always the longest side, always across from the right angle, in this case is going to be the 40. But you'll also notice that one of the side lengths is missing. And you cannot write the trig ratios with a side length missing. Unless, of course, your goal is to solve for that side length. And that's not what the problem asks us to do. The problem asks us to write the ratio. It does not ask us to solve for anything, which means we need to figure out what that side length is. It means we should have a way to find it that doesn't require working with trig quite yet. And we do. Because if you know two sides of a right triangle, you should know how to find the third. We did it earlier in the chapter. Pythagorean theorem. A squared plus B squared equals C squared. Now in Pythagorean theorem, am I picky about the letter A, the letter B, or the letter C? Hopefully you said C. C better be my hypotenuse. So, in this case, that's going to be my 40. Now I'm going to write this below. So I'm going to do 32, that I'm going to put in the A, squared plus B squared. Well, I don't have anything on that side. I can leave it B. I could call it a lowercase j because it's across from angle J, or most commonly, I just like to call it X. If you don't know something in math and variables aren't being used already, you can use variables. So A squared plus B squared equals C squared, and now I'm doing some Pythagorean theorem. Remember, you should be squaring things first. 32 squared is 1,024. That stays X, don't lose your squared on it, equals 40 squared is 1,600. My numbers are on opposite sides of the equal sign, and I want to get my X squared alone, so I'm going to be subtracting this. And I get X squared is equal to 576. And the square root of 576 happens to be 24. So this length is 24. Now, you are going to notice on this problem, I am not going to label my opposite and adjacent. Because earlier I pointed out that the J and the K in my sine, cosine, tangent, and all of those are switching back and forth. Which means, instead of writing it down, I'm just going to have to, each time, start identifying my opposite and my adjacent based on the angle it's asking about. So, first one is sine of J. So I ask myself, SOHCAHTOA, sine is the S, S-O-H. Opposite and hypotenuse are what I'm looking for. If angle J is right here, opposite is on the opposite side of the triangle, so I'm going to go across, and this is the opposite of J. So, sine of J. Just because it's written up so high, I'm not going to just write equals. Sine of J equals opposite, 24, divided by hypotenuse, 40. I simplify my fraction. Let's see. To simplify a fraction, generally speaking, you look at the number that most of the time is smallest, and you start thinking, what divides out of it? Divides by 2. So does 40. But it also divides by 4, and so does 40. Doesn't divide by 5. It divides by 8, and so does 40. And that's going to be the biggest one that divides out of it. If you don't recognize that right away, if you recognized it divided by 2, you would have gotten 12 over 20, and then you should have recognized it divided by 2 again, which you would have gotten 6 over 10, and then you should have recognized it divides by 2 again, which would bring you to the fact that sine of J is equal to 3 over 5. Thankfully, if I recognize that those ones divide by 8, then most likely all of them divide by 8. And if you check on 32, it does divide by 8 as well. Okay, next, tangent of K. Tangent is the TOA. It goes T-O-A. So I need the opposite first, getting divided by the adjacent. Now it's of angle K. Angle K is here. To go to the opposite, I'd go across. 32. Tangent of K equals 32 goes on top over adjacent. The adjacent is the other leg of the triangle that's touching angle K. So in this case, 24. Simplify my fraction. I mentioned earlier already, they divide by 8. Tangent of K equals 4 over 3. Okay, cosine of K. Cosine is Ka in SOHCAHTOA. So C-A-H, I need the adjacent and the hypotenuse. We're working with angle K. Adjacent is the leg right next to that angle. So it's 24 over hypotenuse is 40. That one's consistent. We already established those are going to divide by 8, and so we get 3/5. And I got this before, earlier. I got that for sine of J, and you're going to notice sometimes that happens. Okay, next one, cosine J. Cosine, again, C-A-H, is adjacent divided by hypotenuse. Adjacent to angle J is the 32. 32 divided by hypotenuse is still 40. Simplify my fraction. And we get 4/5. I don't know why I boxed that one in. You could box all of them in. There's nothing wrong with boxing them in. I just haven't been. Okay, we got 2 more and then we're done. Tangent to J. J is here. Tangent, T-O-A in SOHCAHTOA. So I need opposite and adjacent. Opposite to J is the 24. That is the leg that it's touching, so that's 32. Multiply our fraction. They both divide by 8. And I will get that tangent of J is 3/4. Last but not least, sine of K. Sine is the SO part of SOHCAHTOA, S-O-H. So opposite of angle K is 32. And the hypotenuse is consistently 40 because the hypotenuse is never going to change. It's just opposite and adjacent that vary depending upon which angle you're working with. So sine of K is 4/5. So today's focus, making these fractions as well as simplifying them. If you do not know how to simplify a fraction, and I know some of you struggle with simplifying fractions, there is ways to simplify fractions on your calculator, and I'm hoping to be back tomorrow so that I can do that for you and I can show you that. Otherwise, ask another math teacher. There's lots of math teachers. They know how to simplify things on the calculator. I don't care if you simplify it on the calculator. The one thing I do care about, though, is you should not be giving me mixed numbers. For example, 4/3 right here, if you wrote it, some calculators, when you go to simplify that, it's going to tell you it's 1 1/3. I don't want that. There is a way to change mixed numbers into just improper fractions in your calculator too. So make sure that you are giving me the improper fraction, not the 1 1/3. Okay, so today we did section 9 point. That was 9.4. Yep, because we skipped 9.2 and 9.3. 9.4. Specifically, day 1. Okay, this is for Mondays, so it's the 31st. Our homework is due on Wednesday, which is April 2nd. 9.4, worksheet 1. Remember to turn in 9.1 worksheet 1 today and also be amazing for the sub.